In the 1930s, an atomic physicist came up with the uncertainty principle that basically says that when you observe something, you're actually changing something. So you can't actually observe what's happening without actually affecting the way that it happens. That man's name, Heisenburg. The Heisenberg uncertainty principle actually pertains a lot to automotive systems technology. Um, when we start probing and back probing wires, we can actually change the way that that actually system functions. When you're diagnosing a vehicle with something that's not working, say it has a check engine light or a light that doesn't operate, a switch that doesn't seem to be working, when you start unplugging and plugging wires up rather than checking or servicing kind of what's going on there, you're actually introducing observation, in theory, to the circuit, and you can actually cause not really damage, but you may repair something that was just a loose connection without actually knowing what you did. I've seen me, a technician or a future technician, start disconnecting and connecting sensors under the hood once they saw a check engine light was on. And they get back in there, turn the key on, and said, "Okay, so what'd you do?" Unplugged and plugged some things. I said, "Okay, well, what did you unplug and what did you plug up, and what actually caused the problem to go away?" "I don't know." Well, that's kind of what we want to not have happen in an automobile. You know, when we're testing automobiles, we want to know what we're doing, so that way we can repeat this diagnosis the next vehicle that comes in that may have a similar or the same problem. The Hippocratic Oath states that a doctor must do no harm. As technicians, we need to follow that same oath, however, except with people, we shouldn't harm people anyway. We're talking about people's vehicles. Probing and piercing wires is completely different. To back probe or probe a wire means to actually take the wire and the connector and actually go behind the wire and actually touch the wire that way. Piercing a wire means going through the insulation and touching the wire with a probe, such as your multimeter leads, a T-pin, even though are here. You do not want to pierce wires on vehicles. Anytime you pierce the insulation of a vehicle, it actually introduces moisture and corrosion to that component. I do not recommend piercing wires at all. I am totally against piercing wires. You should always back probe at the connector. There are times where back probing is not possible. And if you have to pierce a wire, make sure you seal the wire in a way that no moisture or oxygen gets in that that harness. Many a wire that I've had to replace and fix over the years has been because somebody has pierced a wire and introduced corrosion in that circuit. In the day when, the 70s and 80s, when wiring systems were pretty simple, wasn't such a big deal to do no harm. You had like 32 wires on a vehicle. I'm being facetious here, but there's not a lot of wires. You have plenty of room up in there. You get up behind the instrument panel. You had a lot of space. You can sit here and use your test light and actually get up under there and actually make some good diagnosis that way. However, in today's automobiles, things are a lot tighter, a lot more compact. The wiring systems have become a lot more complex. If you're diagnosing older vehicles, I'm talking about vehicles from the 70s and before then, 12 volts is going to be your common voltage on pretty much everything. If it had power windows, power door locks, wipers, you're going to look for a 12 volt signal pretty much wherever you're looking for voltage there. It's a simple on and off. The button turned it on, 12 volts went to the component, and 12 volts wouldn't be on the component. It would be power or ground. Now with today's vehicles, you can have 7 volts. You can have 5 volts. You can even have 3 volts. These can be pulse width modulated. These can be duty cycled, so you got to know what you're looking for there. On your power probe, it could just be a flickering light there, and that could give you a good reading of this right here. However, you're going to have something more accurate. A graphing multimeter digital storage oscilloscope is great. With 12 volts, you pierce a wire and everything. It'll take a while for that corrosion to create enough resistance if you did some improper servicing there. However, with the smaller voltages here and computer controls that we have on the vehicles today, any little bit of corrosion causes a resistance in that wire, which slows the transmission of data from one module to the next. Anything that you do that disrupts that circuit that causes problems, I say do no harm. Make sure you're backprobe. Make sure you're using the proper equipment. Make sure when you're touching terminals, you're not causing any kind of damage to the female or bending the male terminals in these connectors here. Always do a connector inspection. Make sure your connectors are actually in the right location and orientation. So please do no harm when you're testing these vehicles. Today's vehicles are very complex. There's a lot of different things that's going on here. Without a good wiring diagram, there's no way to do no harm to the vehicle. You're just randomly poking at wires, and you're going to cause bad things to happen. The Heisenburg effect. When you start looking at something, you're going to actually start causing problems with something or actually changing the way something behaves. Many times in a service department, we've caused that to happen because of the way it's been diagnosed. My job is to teach you to not be a goofball. Maybe goofball is the wrong word. I want you to learn how to diagnose things properly so you can actually have job security. Yeah, that. Actually do the job right and actually have a long career as a technician. So do no harm. Always leave the vehicle better off than you found it. We'll talk about piercing and probing just for a moment. Remember I said do not pierce wires. You always want to probe wires. Like with your meter leads, like these are here. If I have some wire, we're all familiar with this wire right here. I have some old Christmas lights here. Wire is a small gauge wire, just like you'd find in an automobile. Again, these are AC, these are not DC current here. They're bad, as you can tell. They're terrible. Piercing a wire. What I'm talking about piercing a wire is if you have a wire right here, you want to pierce it to see if you've got voltage on it. Don't ever do this. 2 reasons for that. As I'm holding this wire in my hand and I'm trying to pierce it, you just can't pierce a wire. You've got to have something up against the back of it there. Now if I'm holding this in my hand and I'm trying to pierce it, you're going to miss. It's going to come off the wire. It's going to sit here and pierce right through your hand. Maybe not through your hand, but you're going to get some cuts and bleeds like that. Don't ever pierce a wire, okay? What I want you to do is to back probe a wire. If I'm going to back probe a wire, like I'm going to check this wire right here, all I'm going to do is I'm going to go up in the back side of this connector here. You can see where the wires come in. The back of there. I'm going to take a T-pin or I'm going to take my probe. This probe is going to be really intrusive because it's about the same side diameter of that wire. If I just probe that in like this one here, I've boogered that connector up. I've boogered that wiring up. I've caused worse issues than I had to begin with here. This is why we recommend using T-pins or small needle-like devices that will slide right between the wire and the insulation and go right up in there. It works really good with weather pack terminals as well. You're going to go up in there until you're actually touching the terminal. Remember, the terminal is the metal part of the wire connector. When you hit the terminal of the wire connector there, then you take your probe here, you can touch right to the T-pin or the needle or the back probe device. They sell back probe devices, which are just small needles, because that's very intrusive. You can see how large that is. That's the same diameter of that wire. If you have exposed wire, yeah, absolutely, you can test for voltage right there all day long without causing any damage. But if you have a connector, such as this, and you wanted to back probe there, not with anything this large, you're going to bust it out, break it out, and cause all kind of problems. So just be aware when you're probing a wire, back probing a wire, make sure you use the right adapter, a small diagnostic pin, I get small T-pins from Hobby Lobby or Walmart. I bought some off Amazon. The smaller diameter, the better, because you're getting tighter spots, tighter spaces there. Most commonly, I'll use T-pins, get up in there, slide in there, touch it if I have voltage, we're great. If I don't have voltage, I may wiggle it around a little bit, wiggle it around a little, just to make sure I've got a good connection to the terminal. But a lot of times when you slide it up in there, you can feel it hit the metal of the terminal there, and you know you've got a good connection there. So just be aware, you don't ever want to pierce a wire, because A, that introduces damage into the insulation itself. It's almost impossible to pierce a wire while holding it without having something heavy against the back jab of it. As you can see, I'm putting a lot of force on it. And now I have damaged that wire right there, and you probably can't see it. I can't zoom in close enough for that, but you can tell a little nick right there. There's a little nick there where I just damaged the insulation of that wire. Don't pierce wires, ever.